Welcome to Physics Lesson 2.08, Part 2 of Vertical Kinematics. Hopefully you have this sheet. I left it with Mr. Gerdeman and asked him to pass it out to you. So we're going to start working through some sample problems and see how the oddities of gravity affect kinematics when we're working with them mathematically. So one of the things we're going to do when we start off is we always need to indicate a direction for our coordinate system. Now we're working in the vertical, so we don't really have to worry about giving ourselves a horizontal. But let's say for all of these problems, we're going to go with, what we'll do is we'll draw an arrow, and then in the beginning we'll put a plus sign above the arrow, and that indicates what direction we have that's going to be positive. Eventually, you'll just put an arrow on the paper and I'll know what you mean. The other thing we want to do is we want to do diagrams. Those are going to be helpful. So I'm going to give myself a windowsill here, and it's sitting above a sidewalk. So here's the sidewalk. The other thing we want to do is we want to indicate what 0 is going to be. So you have to have a 0 point for your direction to start with. Shoot, just hit my, hold on, let me fix my camera. Just bumped it. So let's say the ground is going to be 0. That's going to be y equals 0. That means that my flower pot is sitting at y equals 25, and up is positive, so that's going to be a positive 25. And I'm going to give myself a little flower pot here. You don't have to get so fancy, but yeah, I thought it'd be kind of fun. All right, there's my flower pot. And it falls from a windowsill 25 meters above the sidewalk. How fast is the flower pot moving when it strikes the ground? We're going to start these off much like we do horizontal kinematics, where we're going to give ourselves a vector bank. One of the changes that we're going to have, though, is instead of using x, we're going to replace x with y to indicate we're now in the vertical. So when I do my variable bank, I'm going to have v sub o, v sub f, y sub o, y sub f, a, and t. In the last problem, the y sub o, y sub f really didn't come into play all that much because we were always, our 0 point, it was always start to finish. It's going to change a little bit here, so I'm going to be a little more specific about my y sub o and y sub f. All right, so what variables do I have? I have that it's 0 is the ground and 25 meters is, shoot, I just did that backwards. I'm getting my whiteout out. No, yeah, so I'm starting at 25 because I'm falling. 25 meters and 0 is my final. I did not, I rushed into that, apologies. Now, if up is positive, I know my acceleration. The only thing that's going to be affecting the flower pot is gravity. We're going to ignore air resistance. And so because of that, my acceleration is going to be negative 9.81 meters per second squared. Remember, if I have 3 kinematic variables, I can solve a fourth. But the y's only count as 1, so I only have 2. Well, what's the implied? The implied is that I'm starting from 0 meters per second. They want me to solve for velocity, and I'm solving for final velocity here. And right now, I don't need to worry about time. So when I look at my kinematic equations, the kinematic equation that's going to work for me is v sub f squared equals v sub o squared plus 2a delta y. And remember, that's written as y sub f minus y sub o. All right, so here I go. I'm solving for v sub f squared. I think I'll stay in green. My initial velocity is 0, so that becomes 0. So here I have 2 times negative 9.81 times y sub f is 0 minus 25. When I do my algebra, I get vf squared is equal to, shoot, let me grab my calculator and punch that in. 490.5. One of the things you're going to have to pay attention to is when I solve this, I get 22.1 meters per second. But remember, when you take the square root of something, you get both. It's like saying you have positive and negative 22.1. So it looks like something went wrong because you would have taken the square root of this and you would have said 22.1. Think about the sign. As my flower pot comes to the ground, it is speeding up. And so it's speeding up at 22.1. But what's the other implication if it's speeding up? If my acceleration is negative, that means my final velocity has to be negative. And the correct answer for this is actually negative 22.1 meters per second. Because I had the option of having both, I had to indicate whether it was positive or negative. You can't rely on algebra to give you the right sign here. The next question is, how much time does it take a passerby on the sidewalk below to move out of the way before the flower pot hits the ground? I think a good one to use here would be, so for part B, V sub F equals V sub O plus AT. I now know that this is going to be negative 22.1. This is 0. This is going to be negative 9.81 times time. And when I solve for this, I'm going to get 2.3 seconds. And my signs worked out correctly here. If you had had a positive value here, though, you would have gotten a negative value for time. And remember, time is scalar. So that's a good tip off that maybe something didn't go quite according to plan. All right, let's look at the next sample problem. And to do that, I'm going to have to slide my sheet up. So bear with me here for just a second. In fact, I'll just pause the recording. How about that? All right, I have moved my sheet. So Stephanie hits a volleyball from a height of 0.8 meters and gives it an initial velocity of 7.5 meters per second straight up. So again, we're using this upward, oops, I lost my, that's going to be positive. And we want a diagram. So we've got Stephanie here. And she's going to put it straight up and down into the air. So let me see if I can draw this. She's going to come around and hit it like that. And let's make the volleyball a different color. It's Grove, so let's make a red volleyball. And this volleyball is going to go straight up, and then it's going to come back down. But remember, when it comes back down, it's going to come back down to the floor. So my initial position here, Y sub O, is going to be 0.8 meters. So let's make the ground 0. The implication there is the ground is 0. And we want to solve for how high the volleyball goes. So let's do part A first. How high? All right, I have V sub O, V sub F, Y sub O, Y sub F, A, and T. Okay, I'm in the vertical. So I know that my acceleration due to gravity is going to be negative 9.81 meters per second squared. I'm starting at 0.8 meters. And I want to solve for my height. So I need my final height. Well, if you have 3 kinematic variables, you can solve for a fourth. But right now, I only have 2. So what gives? Remember what we talked about in part 1. At the top of this flight path, my acceleration never changes, but at the top of this flight path, I have, oops, hold on, I forgot to write something down. Okay, so it looks like I have 3, but remember these count as 1. So what do we know about the top of the flight path? We know that if I start out at 0.75 meters per second, as this volleyball goes up, it's going to get slower and slower and slower. And here at the top of the flight path, I get something unique. I get a 0 velocity. So I can use that to solve for my final vertical position. The equation that's going to work for me is v sub f squared. I'm going to run out. Am I going to run out of space? I think I'll be okay. V sub f squared is v sub o squared plus 2a. And I'm going to write delta y this time. So it's y sub f minus y sub o. My final velocity at the top of the flight path is going to be 0. My initial was 7.5, and I have to square that. This is where a lot of math errors come in, FYI. This is going to be 2 times negative 9.81 times y sub f minus 0.8. When I work my algebra out, so when I multiply and divide everything, I end up with negative 19.62y. If you don't believe me, you can go back and do the algebra later. Equals negative 71.95. And when I solve for y, I end up with 3.7 meters. So I start at 8. Now, that does not mean that this is 3. Oh, I think we're recording again. Sorry, I think hopefully I didn't screw up the recording. My cat was getting ready to jump on the desk and he was going to send everything flying, so I had to pause the recording. So what does this mean? What does this 3.7 meters mean? It means it comes up to the 3.7 meter mark. So here, it's the wrong pen. This is 3.7 meters. The alternative to that is it travels 3.7 meters, and I would have to add that to the 0.8, which would be 4.5, but it's not. It means it goes up to 3.7 meters. So part B says, how long will it take the ball to reach its maximum height? So for that, I can do v sub f equals v sub o plus at. My final velocity at the top of the flight path is 0. My initial velocity was 7.5 meters per second. I have negative 9.81 t. So when I do my algebra, I get that my time here was 0.76 seconds. I'm going to save part C for the next video for part 3. And we're going to finish this problem and do one more sample problem. All right, see you in part 3.